Today we can study about modules in Python. Module means it's a small program. It's a small Python program which consists of a collection of functions, classes and variables. Module means it's a small program which is a collection of functions, classes and variables. It is just like a Python program. Its extension will be .py. I don't know whether you noticed or not. When you open a file in Python, its extension will be .py. So, module extension. Module, I told you, module is a file. Its extension is also .py. You can give any name as the module name except the keywords in Python. Keywords in Python cannot be taken as the name of the module. It is just a file which consists of lot of functions. Lot of predefined functions are there. And this module you can use any other program. If you want to use any of the function which is defined inside that module, then you have to import that module within that program. See, that module means it's a small program. That program we can use in another program. The same program you can use in another program by using the statement import. See that I just written an example here, import math. Math is a file. Math is a module name which is already there in the Python. Inside Python you have math.py is there. So which is already present in the Python interpreter. Now whatever the function I am defined or it's defined within that math function, math module, you can use in your program. The functions which are defined inside the math module can be used in your program. If you want to use that function, you have to use a statement import. Import math. That must be there in that program. Then all the functions which are defined inside that math, you can use inside your program. See then, modules are categorized into two. One is built-in module, another one is user-defined module. Built-in modules are already defined inside the inside your Python interpreter. Built-in modules are already defined inside the Python module. User-defined modules are the modules which you can define inside the Python. Is it clear? There are two types of modules are there. One is built-in module and another one is user-defined module. Built-in modules are the modules which are already defined inside the Python. User-defined modules that we can define the module inside the Python. First we can see what are the different types of built-in modules. The first type of built-in module is this one, math module. Math is a built-in module which is already there in the Python. Within that module, lot of functions are defined there. That function we can use in our program. Okay, all the mathematical functions are included in this module. Inside the module math, all the mathematical functions are defined. And I'll show you here, if you see that there is an example is written there, sqrt. Sqrt is a function name. Math is the module name. Sqrt is the function which is used to find the square root of a given number. So sqrt is a function which is used to find the square root of, here in this example, it will find the square root of 64. See that this sqrt is defined inside the module math. So if you want to use any function which is defined in a particular module, then you have to use module name dot its function name. That is why I just use this math.sqrt of 64. What is this math? It is a module name. What is this sqrt? It is a function which is defined inside the math module. Like sqrt, there are a lot of functions are defined inside the math function, a math module. That I will show you here. See, I am going to open the Python here. I am going to use the functions which are defined inside the math module. For that, I am using the statement import math. Just use import space math. If you are using that one, then all the functions inside that math you can use in your program. See, then I am going to see square root. This is just a information. Comma. I want to find out the square root of 91. So I can write math dot which function? Which function is used to find the square root of a number? It is sqrt. sqrt inside the bracket. I just want to find out the square root of 91. So in 91, see the bracket, don't confuse the bracket here. sqrt is a function. So there you are using the normal bracket. And here, this is the closing of the print statement. I'll run the program and see what is the square root of 91. See the first answer. So here, this is the square root of 91. 9 point something. I'll change it. I am going to find out the square root of 81. Square root of 81. That everybody know that. So I'll run the program. Square root of 81. What is the square root of 81? See the first answer. Don't look at here. This is only the information part where all these functions are available in math. I am going to try out these functions here. See the square root of 81 is 9.0. It is displaying us float value 9.0. Okay. If you want to display only the integer value, you can use int over there. Now, next, power. We have a function named pow is there, P-O-W. That I can use it like this. Math dot pow inside the bracket. There will be two argument is there. 2, 4. Can you say what this function is doing? It will calculate 2 raised to 4. Pow of 2, 4. Power 2, 4 means 2 raised to 4 will be calculated. I'll run the program and see the answer. Go through the second answer. The first one is square root answer and second answer. See the second answer says this one 2 raised to 4. 2 raised to 4 is 16. You got the answer 16 there. Understood? So there is a use of POW function. And the next one is cosine value. You can use, that means you can find out the cos value, that which you already studied in maths. Same way, I am going to write math dot cos of 90. Math dot cos of 90. Math dot cos of 90. It returned the cosine value, cos value. It returned the value in the form of radians, not in the degree. Which you studied in maths is degree. Here it returned the value in radians. Now see the answer, third answer. So the cosine value of 90. Cosine value of 90 is this one. See, this is the cosine value of 90. This is in radians, not in degree. Now next function ceil. You can study the function ceil. I can write it like this: math dot ceil of I am going to write 45.67. So ceil function is used to find the smallest integer which is greater than or equal to the given argument. Smallest integer which is greater than or equal to the given argument. Here the given argument is 45.67. Smallest integer which is greater than or equal to this 45. Can you say which is the smallest integer which is greater than or equal to 45.67? Yes, it will be 46. Now I'll run the program and see. See the answer. It will be 46. It will be 46. Now I'll change the number. I am going to write it here. This as 23.12. Can you say which is the smallest integer greater than 23.12? Smallest integer which is greater than 23.12. Yes, the answer will be 24. See, your answer will be 24 here. Yes, it is 24. Right? Next one is floor. Floor is doing the opposite of ceil. Ceil will give you the smallest integer which is greater than or equal to. Now here I am going to write math dot ceil of 45.32. This will give you the largest integer which is less than or equal to the given argument. Largest integer which is less than or equal to the given argument. Can you say which is the largest integer which is less than or equal to 45.332? The answer will be 45. Yes, run the program and you can see the answer here. It will be 45. Sorry, will be. So the answer will be, I just written floor, ceil. It will be floor. F-L-O-O-R, floor. Floor will give you the largest integer which is less than or equal to 45.3. So the answer will be 45 and see the answer. Floor answer will be, it will be 45. See the answer, it will be 45. See the difference between ceil and floor. Ceil will give you the next integer, next highest integer. Floor will give you the nearest integer, next smallest integer. That is the difference. So one more example I'll give you. If I am writing 61.12, what the ceil will give you the answer? It will be 62. And what this one will, I'll change the answer. It will be 89. What this 89.32 will give you for floor? It will be 89. Understood the difference? Right? Now the next one is absolute value. Absolute value. I think you studied in 10th standard in maths. Absolute value. So I can write math dot f-abs of minus 90. Can you say what will be the answer for this abs? F-abs. F-abs will give you an integer number. F-abs will give you the number removing the sign. It will give you the number removing the sign. See the answer, it will give you the number by removing the sign. So that means I am expecting the answer 90. Okay, so the absolute f-abs will give you a float value. That is why it is giving you the answer 90.0. It's remove the sign. So instead of this negative number, if I am giving a positive number, see the answer. So there is no sign over there. You will get the answer 90.0 itself. So if it is a sign, it remove the sign. Now next is value of p. We can use that math dot e. Math dot e. E is a constant. I think you will study that in physics also. E is a constant. Just like pi, e is also a constant. Pi, you know that you studied in maths. Same way, just like pi, we have a constant e is there. So that constant e will be there is no bracket for that e. E is not a function. E is a constant. So you have to use math dot e without any bracket. Okay. So run the program and see what is the constant value of e. Constant value of e is 2.71. See the last answer value of e, it is 2.71. Right? Now the next one, same way we have another constant is there, that is pi, that can represent as math dot pi pi. Only pi is there. There is no pie. There is no function bracket. That is a constant. So both these are constant. That is why I just written together math dot e and math dot pi. Just see the answer of what is it? Math dot pi. Math dot pi will be 3.14. Math dot pi will be 3.14. That you know that. Now the next one is exponent. It returned the exponent value. So you can use it like this: math dot exp of some number. So it will be the exponent of 3, e raised to 3. So here it will calculate e raised to, exponent means e raised to that value. E raised to 3 is this one. Change the answer, change the number. You can see I am going to write e raised to 2. E raised to 2 will give you the answer. Yes, e raised to 2 will give you the answer, exponent 7.38. Now the next one, you don't want to by heart all these answers. Okay, so this floor and cell you should know. The remaining you don't want to by heart it. Nobody will ask what is the answer for this one. It's not possible. They won't ask like that also. Now factorial. So factorial, did you heard the term factorial anywhere? Yes, I know that. I taught you in the last class. Not last class, just 1 month before or 2 months before. Yes, math. Math dot, I can use factorial of 5. Can you say what will be the answer of factorial of 5? How will you calculate factorial of 5? 1 into 2 into 3 into 4 into 5. 1 into 2 into 3 into 4 into 5 is the factorial of 5. Yes, factorial of 5. I'll run the program. You can see the answer. Factorial of 5 as 120. Factorial of 5 as 120. Yes. Now the next one is, this is GCD. GCD, what is this GCD? Did you heard about that term GCD? I think you studied in smaller classes. GCD, greatest common divisor. Greatest common divisor, GCD. GCD of 25,5. GCD, greatest common divisor. Run the program and see the answer. See here there are two arguments, GCD between two different numbers. So here I can show you the answer, that is, so GCD between 25 and 5 is 5. You can try it with other numbers also, try that one. And the next one is remainder. Remainder also we studied. In Python, you will get the remainder by using an operator. Which is that operator? To find the remainder, you know that the remainder you can find out by using the operator percentage sign. So here also we have a function inside the math module. I can use math dot remainder. Math dot remainder, I am going to write 25,5. Can you say what is the remainder after dividing 25 with 5? Yes, it will be 0. So you can say the answer as 0. Here you can see the answer also as 0. Here this is 0. So remainder giving you the answer as float. So that is a remainder. And the next function is here. This one is the next function, that is truncate. Truncate is the next function. Truncate will give you or just remove the places after the decimal point. It's truncate the places after the decimal point. So I can write, say, math, it is math dot truncate, T-R-U-N-C, truncate. I am going to write 65 point, yes. So all the places after the decimal point will be removed and you will get a whole number. You can run the program and see the answer. Your answer will be 65. Trunk, T-R-U-N math dot. Yes, it's correct. Now run the program and see the answer. You can see the answer as 65 here. See, this is 65. Now all the math function I just try out here. From the function name itself, you can say what will be what that function is doing. There are few functions you should know. Others they won't ask the what is the answer for this one, they won't ask, but you should know the purpose of that function. See, SQRT, everybody know that. SQRT is used to find the square root of a number. Now, power, that will find out the power, 2 raised to 4. If you are writing 3, 2, it will calculate 3 raised to 2. Cos 90, nobody will ask you what will be the value of cos 45, cos 90, cos 35, cos 70. You should know what is the purpose of this cos. Cos function will return the radians for the given value. Cosine value in radians. Cosine value in radius. Now, seal and floor. that you should know the value. You should know the purpose and how the value is returning. So whatever the answer, whatever the value you are giving here, so I am going to give 0.67. What is the answer here? What is the seal of 5432.67? It is round to the nearest high integer. So that will be 5433. 5433. There is no decimal part. And here it will be floor. Floor, just keep it in mind that it just remove the decimal point. So that you will get the answer 89. FABs will give you the number without the sign, and e and pi, they are the constants, and here exp will give you e raised to that value. Factorial will give you the factorial. GCD will calculate the greatest common divisor. Remainder will calculate the remainder after dividing the first number with the second number. That means they will give you the same value which you are getting when you use the percentage sign, but the value will be in the form of a float number. Now truncate will remove the places after the decimal point. You will get a whole number. Truncate will give you the whole number after removing the decimal places. So these are the main functions which are used in math module. So that functions I just discussed in the slides. So these are the different slides. You can see here. Yes, sir. There are two types of modules, built-in module and user-defined modules. And we just discussed about the built-in module. Built-in modules are the module which is already defined in Python. And the first type of built-in module is math. Now, these are the different math functions, all these functions which I explained just now. Just go through this function, try out the function in Python. Then only you will get an idea about what that function is doing. Okay? And there is other modules are there that we can study in the next class. Thank you. Thank you, children, once again.